So, homework 3. In this homework, we're covering a lot of definitions, and it's absolutely crucial, you've got a good working understanding of these definitions, so it's a great homework to do. I'm not going to fill in all the answers, but I'll talk you through some of them, and hopefully that will help if you're stuck. Do use the glossary, do go back to what we did in the lessons, and drop me an email if you're still not sure, because these definitions are crucial. Atoms to start with. Atoms are the building blocks of everything. Everything is made of atoms, okay? They're like bricks, I suppose. Bricks that make up absolutely everything. So you can't divide a particle smaller than an atom, okay? Having said that, atoms are made up of 3 subatomic particles, okay? So what makes up an atom? These are the 3 subatomic particles. So can you name those? That's what I want to know there. And then draw a fully labelled diagram of an atom. Now, if you're struggling with that, can I just suggest you look at the front cover of the book. The front cover of the book, the Year 10 Chemistry workbook, there's the front cover. And what do we have on the front? We've got a fully labelled diagram of a carbon atom. So well worthwhile having a look at that if you're struggling. And you can pick any element you want, any atom you want. Elements now. Elements are pure substances. An element is made up of just one type of atom. So if you had a lump of carbon, for example, it would be made of just carbon atoms. So an element is a substance made up of just one type of atom. The list of all the elements, well, Dmitry Mendeleev started that off for us a while ago when he came up with a periodic table. It looked a bit like this. So on the periodic table reads like a book, so we start from left to right and go down the rows like so. So that tells us the last element that's on our modern periodic table is element number 111. So there's about 100 different types of elements, and the list is, of course, the periodic table. Putting them into 2 different groups, so if we have a classroom full of students, we can put them into 2 groups by going down gender, male and female. Well, we don't have male and female elements, but we do have 2 distinct categories of elements. We have metals and non-metals, and of course the dividing line starts here, okay, goes down there, and it steps down here like so. Okay, so that's the place to remember, just there, and then it steps down. Okay, and then we've got elements like iron and gold on this side, so they're of course the metals. And we've got elements like oxygen and carbon and hydrogen on this side, so these are the non-metals on this side. And the dividing line, remember, starts there and steps down. Metals and non-metals on the periodic table. It goes across like that, so hydrogen is in this non-metal side. Right, mixtures. Mixtures are made of 2 or more substances mixed together, combined, but not joined. Okay, there's no chemical bonds. Okay, and we'll look at this a bit more in the next homework as well. But if you take the air, for example, the air is made of 78% nitrogen and 21% oxygen. Now, both of those are elements, so the air is a mixture mainly of 2 elements, but they are not chemically joined. If they're chemically joined, that'd be nitrogen oxide, laughing gas, in other words. So that's completely different. We can separate mixtures. We separate mixtures by physical means. Okay, for example, my desk is often a mess, and I can physically pick any paper up and put it in the bin. I can pick my pencils up and put them in the pencil pot. I can pick the books up and put them on the bookshelf. I physically do that. Okay, so yes, we can separate mixtures. Compounds are made when elements, or atoms, I should say, atoms chemically combine. So hydrogen mixed with oxygen is an explosive mixture. You put a spark to it and you get a huge bang. And when we have that chemical reaction, we form hydrogen oxide or water. That water is a compound. So can we separate the hydrogen and oxygen in water? The answer is it's much more difficult than separating a mixture because they are chemically joined. So we'd have to do another chemical reaction. Only with another chemical reaction is the answer. So no, not really. Okay. Give the formula of the 7 elements that exist as diatomic molecules. Okay, we covered this last homework when we did the balancing equations. Remember, if elements exist on their own, any metal exists on its own, so magnesium would write the formula Mg, or iron Fe. Okay, but these elements that exist combined with themselves are this upside down L that exists here on the periodic table. Okay, it's this upside down L here. Okay, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. If we write those in a chemical equation, we write them with a little 2 after them, and of course we include hydrogen on that. That's the one that isn't in the L. Okay, so it's those. It really, acetylene, we don't really write too much in chemical equations. So we've got iodine, bromine, chlorine, fluorine, oxygen, nitrogen. These are the ones you need to know. 1, 2, 3, 4, 5, 6, and that one there 7. Okay, so that's why we've got 7 gaps here. So we'd write hydrogen, H2. Okay, what are the others? Write them down. Balancing the equation of hydrogen reaction with oxygen. Well, we've already said hydrogen is diatomic, so we have to get this diatomic stuff in. Okay, reacting with oxygen to make hydrogen peroxide. Well, there's the formula of hydrogen peroxide, so we'd have hydrogen peroxide over here. So can you finish that equation and balance it, please? 2 hydrogens there, 2 hydrogens there. Might look balanced, but it's not. Okay, good luck with that.